Welcome! I'm going to do some problems here after the lecture content that I think will be really useful for you because it's what I would call geometric thinking in 3D. Now, first question, without completing the square, make a guess at identifying each of the following conic sections. All right, so we have in the first one, y is x squared minus 2y squared plus 1. Now, look at this. The leading powers here are 2. So, well, this really looks like a hyperbola. It says without completing the square, but I'm going to say that this is a hyperbola. Now, let's complete the square, even though it says don't do it. So, to complete the square, I would want to take this over to the right-hand side and this over possibly to the left-hand side, but we'll see. All right, so we have x squared minus 2y squared minus y and plus 1 equals 0, right? Equals 0. Okay, so I want to sort of pack this part of it together. Now, first thing I would want to do is take out that minus sign in there by putting a bracket around that and changing that to the opposite sign. Okay, so next thing, I need this to be a perfect square. It's not right now, right? So it's a 2. I would rather it be a 4. So I'm going to multiply throughout by 2. So we've got 2x squared and then minus 4y squared plus 2y and then plus 2 equals 0. Okay, is it now a perfect square? Let's have a look. So 2x squared minus, now the square root of 4y squared is 2y. So I want to call this 2y plus something all squared, all right? What would I have to have here? Well, probably, let's guess, a half, right? Because the product of 1/2 and 2 is 1, but when I square, I get 2 of the middle terms, all right? So I have that, but now I've generated something, and it's not quite the same as what's in the bracket there. What have I generated? When I expand this, I have 4y squared plus 2y and then plus a quarter. So there's an extra quarter in here that there's not in here. So I need to now subtract that. So we've got this. Okay. Now we can add those together. So that's 8 over 4 minus 1 over 4, which is 7 over 4. And take that over to this side. Okay, so now we can recognize this as a hyperbola. Now the asymptotes don't pass through the origin. So while we're at it, why don't we just draw this? So asymptotes, hope I spelled that right, but forgive me if I didn't. Okay, so they occur when you change this into a 0 and you factorize this. So the factorization of this left-hand side is root 2x plus 2y plus a half multiplied by root 2x minus, in brackets, 2y plus a half equals 0. So that gives 2 lines. And so with the first one, we've got 2y plus a half equals minus root 2x. Okay, I would take this over, and now this one is the same thing but a plus here. Okay, so then we would have 2y plus a half equals root 2x. For this one equals 0. Okay, so now we want to put this in standard form, divide throughout by 2, take this over to the right hand side, and so we'll get y equals minus root 2 on 2x minus a quarter. And then similarly this, the only difference here would be the sign of that one, so we've got y equals root 2 on 2x minus a quarter. Okay, so these are our asymptotes for that, for this hyperbola here. Okay, so then you could sketch these two. I suppose we should go ahead and do that. So we have an intercept. Let's put that here. An intercept of minus a quarter. So if 1 is there, then minus a quarter is, say, there. This has negative slope. Now root 2 on 2 is 0.7 or so, so not quite a minus 1 slope, a little less steep. So say something like this. And then the other one is the opposite or the mirror image of that. So this is our y-axis, this is our x-axis. So let's try to draw a mirror image of that. Okay, now finally, to finish our drawing of this hyperbola, what we need to do now is find a couple of points by putting one of these in brackets equal to 0. So choosing this equals 0 doesn't give us a point on this horizontal axis there, so it goes the other way. Our hyperbola fits in this way and this way. Okay, so let's now choose x equal to 0. So let's say when, and actually we need to finish this off. So say no real x corresponds to that. Okay, now when x is equal to 0, that's along the y-axis. So what do we have? Well, we've got 0 there, minus sign there, minus sign there. So then we have 2y plus a half equals plus or minus the square root of 7 over the square root of 4, which is 2. Okay, and we can solve this. Take the half over to the right-hand side and then divide by 2. So we would then get y equals minus a half outside of 1 minus or plus root 7. And then we divide all of that by 2, so we change that denominator of a 2 into a 4. Okay, now I need a numerical estimate of that, don't I? That above, we have minus 0.91. Okay, so that's, say, in here on our diagram, almost to a half, being this point, and then on the other side, oh no, so this would be our minus 0.9 or so, you know, not to scale, but, and then this other one is up here, passing through this. Okay, and then these things, branches tend towards those asymptote lines. All right, so this is in fact a hyperbola. All right, let's move on. Now, just looking at that second one, question 1, part B, well, that's obviously a circle, right? Because you can write that as x squared plus y squared equals 2, which is root 2 all squared. So that is a circle of radius root 2 and center 0, 0. Okay, let's move on to part C. We've got y plus 2x is x squared plus 3. Now, what is this? Well, we've got a power of 1 for the y and a power of 2 for the x. So what this is a parabola. Okay, now part D. X squared minus 2y squared equals 4 plus y. What is this? Well, again, hyperbola, because we can take this y over and complete the square. So we'll just say hyperbola. Okay, part E. Y squared equals 3x, or sorry, plus 3x equals 12. So that has a power of 1 for the x and a power of 2 for the y. So that is a parabola. But it's on its side, right? Because if we put this in the standard form, writing x as a function of y, we can see that it's a parabola on its side. So let's go ahead and sketch this one while we're at it. So we have then 3x is equal to 12 minus y squared. Divide both sides by 3, and we have x equals 4 minus 1/3 y squared. Okay, now let's fit this on an xy axis. X here, y here. Okay, so when y is equal to 0, we've got x equals 4. So 1, 2, 3, 4. So that gives us a point. Now, it helps to think about it like this. So you can use the standard way of thinking about parabolas as if this were the y, but now this goes this way rather than this way. All right, so we're looking at what we would be plotting is 4 minus 1/3 x squared. So this is going this way. And so all you need then is the y values when x is 0 to find out where that intercepts the y-axis. So let's go ahead and do that. So we'll say when x is equal to 0, we have y squared is 12. And so taking square roots, y is equal to plus or minus the square root of 12, which is 2 root 3. Okay, let's calculate what 2 root 3 is. So about 3.5 plus or minus 3.46. All right, so if we go 1, 2, 3, 4, it'll be somewhere in here. So this 1, 2, 3, 4, somewhere in here. Okay, so that's a parabola on its side. Okay, back to the problem set. Now, the next one says, by completing the square, classify and sketch the following curves, labeling the x and y intercepts and any asymptotes. But I feel like we've already done this, so how about I'll just jump into 2D. 2-part D. And so we have x squared plus 2x plus y squared equals 3. Okay, I want to complete the square. I can see that this is obviously a circle because power of 2, and there are pluses there, right? And a positive number on the right-hand side. So I need to complete the square on this part of it with the x's. But that's already almost done. I'm just missing a plus 1 here to make that x plus 1 all squared. So it's x plus 1 all squared. And then if I expand this, I get x squared plus 2x plus 1. So I've got to subtract that 1 away. Okay, and now finally we want to take this over to the right-hand side. So that's equal to 4, but let's call it 2 squared because now we can see it as a circle of radius 2 and center. Now we get the center by solving for this equals 0, right? So that is x equals -1, and the inside of this bracket here, well, solving for that equals 0 would give us y equals 0. So -1, 0. Okay, so now let's sketch that. Y, x, okay, let's find our center. Now, let's put that there. So there's our center, so that's -1. Then this would be +1. And this over here would be -2. I'll label it. Okay, similarly, 1, -1. And then we have a radius of 2, so I'd better go up and put another tick there. Let's put a dashed line across here. Likewise down here, -2. And I'll put a dashed line. Okay, so we have a circle centered at this point of radius 2, so oh, well, I can see that this is a little bit imperfect, right? Because I've not done this to scale. Oh well, I hope you do a better drawing. So you're going to see that this does not quite look like a circle. It looks more like an ellipse because I've chosen the wrong scales here on my axes. So, and it's a really bad drawing of a circle then. Hope you can do better. Okay, plan that out a little more. Let's move on. All right, so this question 3 looks like a little bit of a challenge, but that's okay. I hope you're up for it. Okay, recall that the square of the distance between, so d squared between points a comma b and c comma d is equal to the square root of the sum of the squares of the differences. So a minus c squared plus b minus d squared, and then since we're squaring that distance, we're squaring this. So what we get then is a minus c squared plus b minus d squared. All right, so that's the square of the distance. Also recall that by distance between a point and a line, minimal or shortest distance is meant. Show that the parabola y equals ax squared is the set of points that are equidistant to the line x, y. Now, let's draw that line. Y equals minus a quarter a, assuming that a is positive. Let's just put that line here. All right, we'll label it y equals minus 1 over 4a, assuming that a is positive. All right, so there's our directrix. And then we have a point 0, 1 over 4a. So if this is this distance, I better do this to the equivalent scale this time. Okay, so this is that point then. So 0, 1 on 4a. All right, now show that the parabola, okay, so what's that parabola look like? Say something like this, right? Parabola y equals ax squared is a set of points equidistant. Isn't that what it said? Equidistant from the point to the line. Okay, so let's take some generic point, x comma y, draw a line, and then a line. Okay, so this is lowercase d the distance, this is lowercase d the distance, but actually let's put an overline over it because I can see we've used a lowercase d there. So I want to say this is different. Okay, so these are equal. All right, so now our drawing's complete, but that means then that uppercase D squared. Oh, I see. We had a uppercase D for this, and we're using, yeah. Okay, so we'll change this uppercase D. Okay, so these are the distances, but the square of the distances are equal. So if we just start with that as our starting point, okay, so let's say the distance between these 2 points, distance 0, 1 on 4a, to the generic point xy, or distance squared, d squared equals, so just using this formula, the difference between the x's squared, so that would be x minus 0 squared plus y minus 1 on 4a squared. All right, so this is equal to the distance between this point and this point. Now, what is this point down here? Is that what is meant? That is the minimum distance, right? Because if I draw, yeah. Okay, so that from that point will meet at a tangent. I've got to think in terms of a circle here. Okay, so that would be the minimum distance, which meets this at a right angle. Okay, so then that tells me that this point is the point x comma minus 1 on 4a. So then the distance between these two, difference in the x's, is 0 squared plus y minus 1 on 4a, and then squared. Okay, so these two are equal. All right, so now we go to algebra. We've done the geometric thinking, so let's do some algebraic thinking now. So that gives us the square of this is x squared. Squaring this one, we have y squared. Now twice the product of that is minus 1 on 2a y, and then the square of that minus 1 on 4a is plus 1 on 16a squared. Okay, so that then is equal to, now this inside the bracket is y plus 1 on 4a, so squaring that looks like this, except for the sign is different here. So we've got y squared plus 1 on 2a times y plus 1 on 16a squared. Okay, now we can cancel the y squared on both sides. What else? We can cancel these two. These have opposite sign, so this says x squared equals 1 on 2a y plus 1 on 2a y. Now there are two of those that are the same, right? So two of those makes 1 on a. So multiplication by 2 gives me 1 on a times y. Okay, now I've got this equals this. Well, what do I have to do? Since a is positive, presumably, multiply both sides by a, and we get y is equal to ax squared.